This lesson is on subtracting integers. So the first way we look at it is we start on a number line. -3 minus 4 is the same thing as starting with -3 on a number line and then taking away 4. We're taking 4 steps to the left. So 1, 2, 3, 4. When you subtract, then you go to the left on the number line. So -3 minus 4 is -7. A lot of times the subtraction on a number line with smaller numbers makes sense. We're used to knowing that 9 minus 1 equals 8. Because if I start at 9 on the number line and I go back one space to the left, I get 8. So subtraction on the number line visually helps us see that the numbers are going backwards as I subtract. But as we've learned, it doesn't happen that way with every single problem. So we've learned today in class 2 different ways to subtract integers. Now I'm going to go over both methods in this video, and it's important that you pick the method that works best for you. Okay, the first thing that we can do is we have a subtraction problem right here. We can change that to an adding problem by using what's called the additive inverse. It's just like how it sounds. The additive inverse is when you add the inverse of a number. So how I'm going to do that is I'm going to keep the first number. I'm going to change the subtraction sign to an addition sign. That's where the additive part comes in. Now we're ready to do the inverse part. I'm going to change the 4 to a -4. What I did just then was I changed the subtraction problem into an addition problem by doing what's called the additive inverse. Those two problems are stating the same thing. In class, we abbreviated that as the keep, change, change method. You're keeping the first number, you're changing the sign, and you're changing the second number. Now, from here, since there's an adding sign, I'm going to go back to the adding rules. Same signs, add and keep. There we go. I got -7. Let's try another example. So here I have 3 examples. On my 3 examples, I have -5 minus 10. So using the last method, I would keep the first number, change the sign to a positive, and then change the sign of the second number. Keep, change, change. Same sign, add, and keep the sign. Okay, for the next one, I could do it the same way. Keep the 3, change the subtraction to addition, and change the sign of the 10. These are different signs. So now I would subtract, keep the sign of the higher number. When you're using the additive inverse, it doesn't mean that you're going to add the numbers every time. It means that you change it to an addition equation, and then you use the adding integer rules from the last lesson. Now, I mentioned before that there's a second method. Let's look at this second method and see if you like it better. -5 minus 5. I can look at a -5 as a number, and I'm going to add that to another -5. I put boxes around each of my terms here, so I have a -5 and another -5. We learned in class today that a subtraction sign is really a negative sign. So a lot of times in 6th grade, they ask, is that a subtraction sign or a negative sign? And they're really the same thing. So now that I have a -5 and a -5, those are both negative numbers, so same signs, add and keep. I could do the same thing down here. I have a +10 and a -2. They're different signs in the boxes, so I subtract. The second method in blue is very much like mentally calculating it. It's a little bit harder to grasp, so I think if you spend a lot of time practicing the skill first using the additive inverse or the keep, change, switch method, it will be helpful for you. Let's come up with a couple more examples. I have a -8 and I have a -2. Same signs, add and keep. I have a +5 and a -8. Those are different signs, so I subtract and I get -3 because the 8 has the higher absolute value. Keep in mind, if these are confusing, just write it as the additive inverse. Keep, change the subtraction to an addition sign, change your 8 to -8. This one's -4, and then here's the tricky one. -6 minus a -2. Now I could do the keep, change, switch method, and it works out really well for this type of problem. Now I have different signs subtract. But say you were trying to do it that mental calculation way. Well, now we have a different trick here. I'm going to take this part of my number and I'm going to rewrite it over here. The opposite of -2. Well, the opposite of -2 is a +2. We learned that last unit. So you can replace that with +2. The opposite of a negative number is going to be positive. A visual way that a lot of people use with these types of problems is if there's a negative sign next to another negative sign. And those are parentheses, not absolute value signs, because you can't do that. But if they're parentheses and there's nothing else inside the parentheses, I can change those two negative signs into one big addition sign. So here I go. I have -6 plus 2, which is -4. Let's see if I can find some other ones that are similar to that problem. -10 minus a -15. I see two negative signs right next to each other. I'm going to turn them into one big plus sign. -10 plus 15 is a +5. Those are different signs, so I subtract. And now look at my new problem. 15 is a positive number, so my answer is going to be a positive number. You do the same things even with these fancier ones. I'm going to change that one. Different signs subtract. Oh, different signs again, so I better subtract again. At any point during these videos, feel free to pause the video, solve the problems by yourself first, and then you can use it to check your answers.